Picture this: you wake up, open your phone, and the first notification says, "We found life on Mars." Your heart stutters. Coffee goes cold. The world stops scrolling and starts listening. What would that announcement actually mean? And how close are we, really, to hearing it for real? Let's start with a simple, unsettling truth: Mars is not the dead, quiet world many imagine. It's a crime scene, ancient, windy, sand-blasted, where the clues haven't been erased, just scattered. Our job is to collect them, line them up, and ask the biggest question a species can ask: are we alone? Clue 1: water. Not wishes. Not rumors. The bones of rivers still trace across the Martian surface, braided channels, carved valleys, and a fossilized river delta fanning into a crater called Jezero, where NASA parked the Perseverance rover. Deltas are nature's scrapbook. They layer mud, silt, and chemistry over time like tree rings. On Earth, deltas are life magnets. On Mars, a delta that survived billions of years is more than geology. It's a time capsule labeled "Open carefully." Clue 2: the chemistry of life's building blocks. The Curiosity rover drilled into ancient lakebeds in Gale Crater and found organic molecules, carbon-bearing compounds, in the rocks. That doesn't scream aliens. Organics can form without life. But here's the kicker: those organics are preserved in places that used to be wet, protected by minerals that lock in delicate chemistry the way amber traps an insect. If you were writing a cosmic treasure map, organics in an ancient lake is a bold red X. Clue 3: methane. On Earth, a lot of methane comes from life, from microbes to cows to marshes that exhale gas as they digest. On Mars, instruments have sniffed whiffs of methane that rise and fall with the seasons, sometimes spiking like a heartbeat. Is Mars breathing? The mystery gets weirder: one spacecraft sees it, another doesn't. The atmosphere is thin and the chemistry is harsh. Methane shouldn't last long. So if it's there, something is making it, or releasing it. Maybe it's geological, serpentinization in rocks, gas trapped in icy cages. Maybe it's biological, ancient microbes waking and sleeping with the temperature. The plot is thick enough to stand a spoon in. Clue 4: a 1970s cliffhanger. The Viking landers ran a labeled release experiment: feed Martian soil a nutrient cocktail, see if anything burps gas back. It did. That's right, one of the first life tests on another planet gave a positive signal. But a different Viking instrument, a tiny oven designed to sniff organics, found nothing. At the time, many scientists called it a false alarm. Later we learned about perchlorates, salts in Martian dirt that can destroy organics when heated, masking the very evidence that oven was trying to smell. So Vikings yes and Vikings no have been staring at each other across a laboratory table for nearly 50 years. Today, that stalemate feels less like a dead end and more like a sticky note that says, "Revisit with better tools." Clue 5: the Martian meteorite with a tabloid headline. In Antarctica, scientists found a rock blasted off Mars ages ago. Inside, some saw shapes that looked like microfossils, plus minerals that, on Earth, can be associated with biology. The debate got loud, then cooler, and today the consensus leans probably not life. But here's why it still matters: it taught us what standards the claim must meet. Not interesting. Not suggestive. Overwhelming. So what, exactly, would count as groundbreaking evidence? Imagine 4 spotlights lighting the same object. First spotlight: structure. Under a microscope, you see cell-like shapes, not once, not twice, but in multiple samples taken from layers that make geological sense. You see patterns, branching filaments, membranes, Colonies, things random chemistry doesn't tend to build at the same scale, in the same place, in the same way. Second spotlight, chemistry. You detect complex organics that look arranged rather than tossed together. On Earth, life favors one hand of a molecule, left or right, over the other, a phenomenon called homochirality. If Mars rocks whisper that same preference, it's like finding a diary written in the same handwriting across different pages. Third spotlight, energy. Life runs on gradients, chemistry that flows from high to low like water down a hill. You find minerals and isotopes that imply metabolism, sulfur, iron, or methane cycles that would leave behind specific chemical fingerprints. Not one odd reading, but a pattern that says, something was eating, breathing, and excreting here. Fourth spotlight, redundancy. Different instruments, different methods, different locations, same result. Rovers see it. Landers drill it. Orbiters infer it. Labs on Earth validate it in samples with pristine handling. The evidence stands even if any one instrument fails. If 2 spotlights flicker, it's interesting. If 3 lock on, the room goes quiet. But if all 4 blaze at once, you don't need a press release, you feel it in your spine. Now, how would a discovery like that actually unfold? Not with a single dramatic line. It would begin as a whisper. A team publishes an odd isotopic ratio in a mudstone from an ancient shoreline. People raise eyebrows, but they want replication. A second team, different crater, finds organic compounds that skew in molecular handedness. Eyebrows climb. Then a drill core from deep in a delta turns up microstructures with layered membranes, preserved in iron-rich minerals that can gently fossilize cells. The photos aren't blurry. The chemistry matches the shapes. The ages line up. Suddenly, simulations that once could explain a weird spike start to look like acrobatics. Skeptics do what they should do, they try to break it. They fail. The whisper becomes a voice. The voice becomes a chorus. That's when the practical questions crash in. Planetary protection, if there is, or was, life on Mars, what are our obligations to it? Do we risk contaminating our cousin with our own microbes? Do we risk bringing something home we don't fully understand? The answer isn't to panic, it's to respect. We can sterilize. We can quarantine. We can study safely. But we also have to admit that the moment we confirm life elsewhere stops being a blank page and becomes a place with its own deep history. Let's zoom back to the rovers for a second, because they're not just tourist buggies, they're prosecutors building a case. Perseverance is caching samples in little sealed tubes across an ancient river system. Each tube is like a paragraph in a story only microscopes can read. When those samples are eventually studied in Earth labs, whether by a multinational mission or next-generation instruments on Mars, the test won't be "do we see something cool?" The test will be, do multiple laboratories, using multiple techniques, reach the same conclusion without contamination? Life is messy. Science is too, until the results stop moving. And if the verdict is yes? If ancient Martian microbes once wriggled in warm, briny lakes beneath a pink sky, or if something sheltered in the subsurface even now, clinging to mineral veins and a trickle of chemistry, then the implications are outrageous in the best possible way. It means life isn't a miracle lottery ticket you win once in a galaxy. It's a tendency. Give the universe rocks, gradients, time, and a little water, and life pushes in like a weed through concrete. It also reframes a harsher question: why didn't Mars keep going? Why did Earth bloom with continents of forests and oceans full of whales while Mars seems to have frozen out? That comparison would teach us about climate, magnetism, atmospheres, and fragility, lessons that point right back at our blue home. Maybe the most thrilling part is this: groundbreaking evidence won't feel like a single door opening. It'll feel like many doors swinging inwards together, revealing a hallway that's been there all along. Methane hints. Organics whisper. Deltas gesture. Ancient hot springs point. Viking waves from the 70s with a cryptic smile. When the confirmation comes, we'll realize the groundwork was under our feet the entire time. So here's a thought experiment to end on. The day that notification hits your phone, what headline do you want to read? Signs of ancient microbial life discovered in Martian Delta. Multiple lines of evidence confirm past biology on Mars. Present-day subsurface microorganisms detected by in situ experiment. Each is possible. Each is a different flavor of profound. One rewrites our past. One changes our present. One opens a future where bio is a solar system word, not just an Earth one. Until then, keep your curiosity packed and ready. The universe rarely shouts, it leaves trails. And right now, on a cold red world not so far away, the trail looks less like random dust and more like footsteps. If this journey lit up your imagination, tell me this: which clue convinces you the most? The rivers that once ran, the organics locked in stone, the methane that won't behave, or the experiment that said yes before we were ready to hear it? Drop your answer. I'm reading. And I have a feeling that someday soon, we'll all be reading something extraordinary together.